How you doing today, guys? Welcome back. This is Alex Gomez, your favorite teacher in the whole world. Today we're going to talk about similar shapes and proportions. Okay, just a little reminder about what similar shapes are. Let's take this piece of paper right here. If you look at this piece of paper, what shape is this paper?
Rectangle.
Rectangle, right?
Triangle.
Okay. So this is a rectangle. What about this one right here?
Triangle.
Rectangle.
It's a rectangle.
It's also a rectangle. Okay? Two rectangles.
That's
Now, it's just what?
It's just smaller.
It's just smaller, okay? So this is what we're talking about, similar shapes. In order for a shape to be similar, they have to be the same shape, but they don't necessarily have to be the same size. They can be the same shape but different size. The only other thing, there's two things that have to happen. They have to be the same shape, and they have to have the same angle. If the numbers are the same, but the angles are different, then they're not going to be similar. So, for example, how many degrees is this corner right here? 90. So what about on the small one?
90.
It's also 90. So all the corners of a rectangle are going to be 90. Now, one thing to remember, a square is always similar and proportional. Okay, always. Whenever you have two squares to compare, they're always going to be similar and proportional. That's only true for squares. Now, why do I say angles are important? On rectangles, it doesn't matter. But whenever we're talking about triangles, it does matter because we have different shapes of triangles. We have isosceles, scalene, obtuse, acute, right angles, things like that. So we're going to learn about that. Now, just a little preview of what's going to happen. Let's look at this rectangle. If I call this to be 4 and this to be 8, so the width is 4 and the length is 8. Remember those. Width is 4, length is 8. And on the small one, the width is 2. What is my length? How do we find that?
Could you cut it in half?
It's just a half, right? You double or half it. That's what happened. These are not proportional. Let's pretend they are. So if this is 4 and this is 8, on the small one, this is 2. So they has to be 4. We just doubled that, right? That's essentially what we're going to be doing. So now, let's look at the worksheet. Everybody has this piece of paper, and that's what we're going to be doing. So it says figures, similar shapes and proportions. Figures that have the same shape but not the same size are similar. So again, they have to be the same shape but not necessarily the same size. They're similar. In similar figures, the ratio, that's a key word. The ratio is like when we said the 4 to 8, 2 to 4, we multiply by 2. 2 is the ratio, 2 to 1. When I showed you the piece of paper a minute ago, that's the ratio. We multiply by 2 or divide by 2, that is going to be the ratio. The ratio of the lengths of the corresponding sides are proportional, and the corresponding angles have equal measures, okay? They have to be, the corresponding sides have to be proportional, and the angles have to be the same. Now we're given these two samples right here. We have a right triangle and another right triangle. These two, they're already similar. So let's see what's happening right here. It says to determine if triangle ABC is similar to triangle XYZ, you can write a proportion for each pair of the corresponding sides. So they basically took corresponding side to AB, which is this one right here. The corresponding to this one on the small one is going to be which one?
X1.
XY, very good. Now the corresponding, let's use a different color. The corresponding to BC is going to be YC, very good. And the last one, of course, is going to be right here. Everybody can see that, right? So, essentially all they do is took the corresponding sides and made a proportion or a fraction. And then simplified it to the simplest form, and that is the ratio. So AB equals to 15. The corresponding to AB, we said is XY, which is 10, right here. Then you have 15 over 10. If you simplify, in this case, you can divide both of them by what?
5.
By 5. So if you divide both of them by 5, you get 3 and 2. Easy, simple. The next one, 12 to 8. Okay? In this case, what do we divide it by?
4.
By 4. And you get also 3 halves. Now, whenever you're doing this is already proportional. Don't stop at the second one because the third one might be incorrect. Okay? When you divide by 4, you get also 3 halves. And the last one, you get 9 over 6. Which you divide by 3. Simplify, you get 3 halves. So the ratio for this one is
3 over 2.
3 over 2, 3 halves. You can also find the ratio written in different ways. You can also see it written like 3 dot dot 3 colon 2, like that. Or you can also see it like 3, 2, 2. Either way, fraction or with the colon or with the word TO is the same thing. Okay? Any questions so far?
No.
So far so good? Now there's another thing that I want you to know. It's a segment. A segment, for instance, is going to be the line, the name of the line. So like for this one, segment AB, you can also find it written like AB with the line on top. It's the same thing. Okay? Just in case you see it, you know what that is. That means that it's talking about this line right here. So far so good? Okay, now we have 4 examples on the bottom. And we're going to find if their shape is similar and explain the reasoning. So number 1, and this is what I like to do. I like to label everything and then just fill in the blanks. And I have posters for that, so I'm going to look at the figures. I have a big figure and a small figure. Everybody agree with that? Yes? So I have a big figure and a small figure. And I'm gonna, instead of labeling like that, this one was really easy because I have different colors. But whenever you don't have different colors, you can use the pen and identification line. So I like to use tick marks for this. So for this one, it doesn't matter when you start on the first triangle. Look at the first shape. Now this is not hard, it's time consuming, so just pay attention real quick. So I'm gonna call this 1 tick mark, 2 tick marks, and then 3 tick marks. Okay? Now I'm gonna find the corresponding size to each one of those on the smaller triangle. So what is the corresponding to the 1?
80.
Which one is corresponding to 1 tick mark?
4.
The 4. So I'm gonna put in 1 tick mark. Which one is corresponding to 12?
6.
So I'm gonna put in 2 tick marks. And corresponding to 16 is? 8. Another thing that you need to remember, every time you have a triangle, the longest side is called the hypotenuse. We're gonna need that later on, okay? The longest side is always gonna be the hypotenuse. Now, things that you need to know. If you're going from big to small, you have to expect that the numbers on the small one are gonna decrease. And if you go from small to big, the numbers of the big one have to increase. Common sense, guys, okay? Use that a lot. So now that I label this, now it might seem like a lot because I'm talking and explaining it, but because I want you to get it. Now what I'm gonna do is write a proportion. I'm gonna do the big over the small. Big over the small. And then I'm gonna put in my labels, my tick marks. 1, 2, and 3. Just like that. And I'm gonna do 3 fractions. 3 fractions. So all I have to do is look at this and fill in the blanks. Because these are fractions right here. These are fractions. So what's B1? What number is B1? 10. What's B2?
12.
12. What's B3?
16.
Now what's S1?
4.
What's S2?
6.
And S3?
8.
8. So now all I have to do is simplify it like on the first example. Okay? Let's go ahead and simplify. Some of these you might be able to do in your head. Like right away, really quick and easy. Okay? So, let's simplify this. 16 divided by 8 is 2.
Sorry.
12 divided by 6 is
6.
12 divided by 6 is 2.
I'm sorry.
Now what's 10 divided by 4?
2.
No,
It's not 2. It's 2.5. Now one of them,
it's not proportional.
2 were proportional, but one is not. So this is not proportional, not similar.
I have a question.
And then you stop. Yes, sir.
Wait, but you don't. Wait, why don't you like look at the shape itself and you can see this is smaller than the other side? Over here? Is it smaller on that side?
What do you mean?
Because if you look at the right here, it's smaller than that side. It doesn't
Oh,
look-
if the drawings they might not be to proportions. You have to look at the numbers and set up the fractions, and then figure it out with math. Okay? Because if you look at some of the squares right there, they don't look like squares. Like on this one, you look at this, that doesn't look like a square. But if you look at the numbers, you can tell it's a square, right?
Yeah.
Because all of the sides are 13. Even though it looks like a rectangle, it is a square because look at the sides. Okay, where? Okay, not similar. So this is not similar because one of them is not. The other way that you can see this is just look at this. What happened from 16 to 8? Now, whenever we're talking about proportions, ratios, factors, scale factors, we are either multiplying or dividing only. There's no adding or subtracting. Multiply or divide. So don't say it subtracted 8. No. So what happened between 16 and 8? Or between 8 and 16? What happened? Just by looking at it. 8 times what gives you 16?
2.
2. So let's take that 2. 6 times 2?
12.
Is that 12?
Yeah.
4 times 2?
8.
8. Is that 8?
No.
It's not proportional. You can see it like that too.
That's easier.
That's easier. But I'm showing it's not always going to be easy. Because sometimes the number is not going to be an even number. It might be a fraction. So I'm going to show you something. So let's look at number 2. Let's look at number 2. Now, this one, they label the angles, all 3 of them. But they don't label any angles on this one, so you can expect them to be the same. If they don't label the angles on the other one, they're the same. Expect them to be the same. Now, if some of the angles are missing, you can find them. Now, because if we look at this one right here, how many degrees is that?
37.
Do I have anything here?
No.
I gotta make sure this is 37.
Yeah.
What is this right here?
33.
Well, do I have anything in there?
No.
I have to make sure that is also 53. This line right here, 90. Do I have a 90?
Yeah.
Yes.
Now, remember, triangles. What do we know about triangles and angles?
Get
The
both sides.
degree is 180.
The total degrees for the inside angles, sum is 180. Very good. So, if I have 180 minus 90 minus 37, it is 53. So this one is 53. Now on this one, 180 minus 90 minus 53 gives you 37. You can find the missing angles. You just have to remember that the sum of all the 3 angles is 180. So far so good?
Yeah.
Let's go back to number 2. We have the labels for the 3 angles, no labels here. So that means that the angles are the same. If there's no labels right here on the second one, the angles are the same. You're assuming that they're the same. Okay? So, again, are we going from small to big or big to small?
Big to small.
Big to small. So we're going to do the same thing. Big small. So big over small. 1, 2, 3. Now, does it matter, if you look at the first triangle, does it matter where you first put it in the first tick mark?
No.
It doesn't matter. You can put it here, here, or here. It does not matter. It matters when you translate that tick mark to the other one. It has to be on the corresponding side. Okay? So, for the sake of simplicity, the first tick mark, I'm going to use the smaller number. So, 1, 2, 3. So, what's corresponding to 16 on the small one?
12.
12, 2, and 3. Everybody agree?
Yes.
1, 2, 3. They're oriented the same way. That's all good? So all you have to do is put them like that. Now, what's B1? We're going to label it. B1 equals
16.
16. B2?
24.
B2.
20.
24.
20.
Oh.
And B3? 24. S1? 12. S2?
15.
And S3, 18. Now we gotta simplify this and make sure we get the same number on all of them. Okay? So what can I divide these two by? 16 over 12. Divide by
2.
by 4. We can divide by 2 or all the way to 4. So if we divide both of them by 4, you get 4/3. Right? 16 divided by 4 is 4. 12 divided by 4 is 3. What can I divide the next one by?
5.
By
By 5. So 20 divided by 5 is 4.
3.
The bottom is 3. So far, so good, right? What about the last one? What can I divide them both by?
2.
6.
By 6. 6 is the common multiple, right? 24 divided by 6 is 4. And the bottom is?
3.
So is it similar?
Yes.
What is my ratio?
4.
4 to 3. That's it. Any questions on this one? Easy? Let's look at number 4. Are they similar?
Yes. No. Yeah.
Yes.
Yes?
really,
Yeah, they
Are the measures the same? The numbers? The inches the same?
Yes.
The inches are the same.
I see 75.5 now.
First of all, are they the same shape?
Yes, it's just slanted.
Is it the same shape?
It's a rhombus.
It is not a rhombus. Okay, what shape is this? Square. Square. 13, 13, 13, 13. Square. What about this one?
It's a
I thought it was a diagram.
Parallelogram. Thank you. Parallelogram. So they're not the same shape. You can stop right there. Not same shape. Look at the angles. These are 90s. What's the sum of the angles of a square?
90.
Sum of the angles of a square. 360. 90, 90, 90, 90, 360. Okay? You need to know that. The four corners, they're the same thing on a rectangle, right? So, what about this one? This is not 90. Just to start with, you can look at the angles. You can look at the shape. It's not the same shape. The angles are not the same. Therefore, it's not similar, not the same angles. The angles are different. Any questions on that one? Now, the last one I'm going to do for you, number 3. Are we going from small to big or big to small?
Big to small.
Big to small. So where do you want the first tick mark to be at?
Who did the biggest one?
Now, can you do this one on your head? Maybe. But if not, we can do math, right? So I'm going to do 1, 2, 3. Look, the hypotenuse is always the longest side. So corresponding to 1 is 12. So that's 2, and this is 3. So B over S, 1, 2, 3. So what's B1? B1's 36, B2,
54. 12.
54, and B3, 72. S1, 12, 18, 24. Any questions so far? No? All we have to do now is simplify. How many times does 12 go into 36?
3.
6.
3. 12 times 3 is 36. What about 18 into 54? Remember, it's just top in, bottom out, right? It's also 3. And the last one is also 3.
It's proportional.
So it is proportional, yes. What is my ratio?
3. 3.
So whenever it's a whole number and you need to write it as a ratio, it's going to be 3 to 1. Very good. 3 to 1. Any questions so far? Easy? Now there's another way to find out if they're proportional, and I'm going to show you on this section right here. I'm going to draw 2 rectangles, 2 triangles right here, this area. So I'm going to draw this one, and then I'm going to draw this one. Okay? Now, this is most likely what you're going to be seeing on your test. They just didn't rotate it only, they also flipped it. So again, I'm going to use small numbers to prove this one. I'm just going to use small numbers. So I'm going to do 3, 4, and 5. And then this one is going to be 6, 8.
10.
So that's 10, right? What's my ratio? What's my ratio? 2, right? I multiply by 2. Now, if I don't know that this is proportional, I can find out a different way. Again, I'm going to take 1, 2, 3. 1. What's my corresponding to 2? 8. And my corresponding to 5? Right there. So, small over big, 1 and 2. I'm going to use 2 of them for now.
5, 2.
What's S1? Because we're going to do it separately. What's S1?
3.
3. S2?
6.
4. B1? 6. And B2? 8.
8.
Now, to find out if they're proportional, this is a different method. All you have to do is multiply 3 times 8. 3 times 8 is? 24. And then 4 times 6 is?
24.
If the number after you multiply is the same, it is proportional. So now, we only multiplied 2 of them. I gotta check another side. The missing one, right? Because I haven't done this one right here. Even though I know, I gotta check that. So I'm gonna take either 1 or 2 and compare it with 3. I'm gonna use 1 because it's a smaller number, right? So I'm gonna do 3/6. It's gonna be 5, 10, right? Yes, this is 3 right here, and this is 1. So what's 3 times 10?
30.
30, and 5 times 6 is?
30.
So are these the same number?
Yeah.
So it is proportional. But you gotta check them 2 at a time. You cannot check them all 3 at a time. Any questions so far? Well, guys, yes, sir? That's it for today's. You have a good day. Thank you.